All right, so instead of going on to do the circumscribed circle, we're going to try to solve this problem. How can we find the perpendicular distance from this point to any one of the sides? And so you have one idea so far, but it didn't work. But what was that idea?
You can fold this point to this point.
Okay.
And you get a perpendicular bisector.
All right, you get a perpendicular bisector.
But the perpendicular bisector won't necessarily pass through this point.
Right. So let me ask you something. Tell me what's good about the perpendicular bisector idea.
Well, it gets us a perpendicular line.
Okay, what's bad about it?
It doesn't cross this point.
It doesn't necessarily cross that point. So it's not, although it doesn't work, it's not like I said fold the corners of this rectangle, or of our square across each other, because that would have nothing to do with the triangle or anything. The perpendicular bisector actually is close to solving the problem. Again, what's good about it?
We get a perpendicular line.
We get a perpendicular line, which is what we're looking for. It just doesn't go through the point we're looking for.
Yeah.
But how can we like move that fold over? Like just folding like this necessarily create a perpendicular line?
Like what? What do you tell me what you're doing?
I'm putting this point to like a point, say here.
Okay, so why don't you do that?
And then
You're putting
You're
that.
trying to get the crease lined up.
yeah, I'm trying to
on
get the
point.
crease lined up with our point sort of like that.
Okay, now let's be really careful about this. Let's double check before we crease it. Let's make sure that it's lined up.
I see the point. So
Yeah, the point is lined up.
Okay, so before we crease it. All right, now crease it. Like go back this way to crease it because it's pinched a little bit. Okay. All right. So what was our process here?
So we didn't fold the corner to the other. We didn't fold the corner of one side to the other corner of that side. We lined up a crease on the point.
And where did you put the corner?
The corner was just on the side, not necessarily at the other.
Yeah, it was on the. It was still on. It was on the side, and you can see how close we were
To our other.
line, because our triangle is pretty close to an equilateral triangle. You can see we're not quite on that
I
line.
think it's this line here.
Okay, but that's all right. It's just an unlucky coincidence. But we could do that with all the sides, or what? What should be the case?
Or we could use our compass here
Okay.
and measure out this radius here.
Yep.
And then we can just draw the circle.
Okay.
Sort of faint on patty paper.
Yeah. See if you can press it down just a little bit harder. Oh wait. Watch the shadows. Get in the middle there. Get in the middle of that point.
Yeah.
Okay, and when you go past the edges, stop. Stop when you're touching the edge.
Here.
Oh, shoot, your hand's in the way.
That.
Yeah, it's right on the edge, which is cool, even though that it's not leaving a mark.
You can kind of see it. Right
Yeah,
across
and
there.
then there it's right on the edge. And there it's right on the edge.
Cool.
All right, now pull it away. And oh yeah, it's funny, the sort of crease from the pencil that actually shows up on camera.
Yeah.
And there we go.
Cool.
So we have found the inscribed circle just by folding. And in fact, now that we've done that, we could actually find the area of this triangle. How? How would we do that, given that we have a ruler?
Well,
We don't have to do it, but how would we do it?
are we allowed to measure with the ruler?
Yeah, well, your choice is whack your brother or measure with the ruler. Which would you like to do?
Alright, so then we can measure out the sides.
Okay, we could measure the sides.
We can measure this radius.
Uh-huh.
And then we know the area is the semi-perimeter. because it's half the perimeter,
Yeah.
times the radius.
Uh-huh.
So we can find the perimeter from radius.
Yeah. So if we have a ruler where we can measure the side lengths,
Yeah.
and we have just a little bit of folding, we can actually find the area of a triangle.
Cool.
Yeah. That's pretty neat, actually. That's a fun, petty paper geometry is really fun. All right, good work, guys.